September 27th, schedule assessment 2 will be out there. My goal for y'all for schedule assessment 2 is to make it 50%. And my goal is for your pie to be at 50% or higher. And my goal is for you to be out of module 2. Okay? So some of y'all are still in module 1, which means you have been in module 1 for over a month now, boys. And so if we've been in module 1 for over a month now, and we ain't even in module 2, and I want you out of module 2 in 2 weeks, then we need to be getting to work. So I want you out of module 1 and out of module 2 by the end of this month. And y'all, I am riding you hard right now because come the end of the semester, you're not going to like me because you're going to be worried about all your other classes, and I'm going to try to get you out of here. So I'd rather rush you now and make you learn it now than make you get it at the end of the semester. Because if we can get you done with this course now, then you don't have to worry about me at the end of the semester. Okay, so that's your goal over the next 2 weeks, is to get a 50% on your pie and out of module 2. Now, I have a couple of things that I've been asked. The first one talked about 38%, your population decreased by 38%. The current population is 279. What was the value when it was purchased? That one, what are you in now, Michelle? Module what?
2.
Okay, module 2. This is a module 2 question. I'm going to pull it over here. This one is a little bit harder concept, and the reason it's harder is because they're giving you the current value. So what you have to do is you have to take the previous value. So the previous value minus, and we're subtracting it because it was decreased, 38% of the previous value equals the current value. So whatever, it's kind of like when we were doing that, if you decrease the price, a lot of y'all are working on that decreasing the price problem. So whatever the value used to be, whatever the population was, we decreased it by 38% of that population to get what the population is now. So I'm going to call my population P. So P minus 0.38P. And y'all, I got my 0.38 by doing the whoop whoop. The whoop whoop. And we're going to talk about the whoop whoop in just a minute. 38%, I took my decimal and I did my whoop whoop and made it 0.38. And my current population is going to be 279,000. Now, there's an understood 1 right there. And because both of these are P's, I can put them together. So in my calculator, I'm going to do 1 minus 0.38. So when I put those two together, that gives me 0.62P equals 279,000. Now, what do I need to do to get P by itself? I'm going to divide by 0.62 so that those cancel. So in my calculator, it's going to be 279,000 divided by 0.62. Now, I will go ahead and warn you, anytime you're doing these problems, your answer is always going to be pretty because they didn't tell me to round. So if you end up with 429,736.425 blah, 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 you got it wrong. Your answer is always going to be a pretty number. Now, if this would have said increase, like if I would have taken this same problem, clone, let me move it down for just a second. If I would have taken this same problem and changed this one word right here to increase, which is what Alex is going to do. If I change this one word to increase, then this is going to turn into a plus sign. So it's going to be the previous value plus 38% times the previous value equals 279,000. So whatever the population was, we're now adding 38% of that number. So it's going to be 1p plus 0.38p equals 279,000. Now this one may not be pretty because I just made it up. So 1 plus 0.38, I can put both of those together because they're p's. So when I put these two together, I get 1.38p equals 279,000. And then I'm going to divide by 1.38. So if you're increasing, you add it. If you're decreasing, you subtract it. I can't type. 279,000 divided by 1.38. Again, I made this one up. That's why it's not pretty. If Alex would have given it to you, it would have been pretty. But do you see the difference? If it says increase, you're going to add it. If it says decrease, you're going to subtract it. We good? Mm-hmm. Does that help? Mm-hmm. Now, another problem that I saw several of y'all in today was changing a percent to a decimal and a decimal to a percent. This is also a Module 2 problem I won't get to for several days, but several of you were on the struggle bus with it today. Several of you have gotten through it, but don't know how you got through it. So, I want to make sure that I go over it. This is, hold on, I'm going to get it. This is this one. How do you change a percent to a decimal and a decimal to percent? And we may have talked about it, but I want to make sure I go over it again. If you're changing a decimal to a percent, you pick up your decimal and you move it 2 times to the right. If you're changing a percent to a decimal, you pick up your decimal and you move it 2 times to the left. This is what I call the whoop-whoop. Alex talks about dividing by 100 and multiplying by 100. I can never remember when do I multiply by 100 and when do I divide by 100. So, if Alex gives me a problem that says write 2.5 as a percent, this is what Ms. Cooper always does. I said, what did they give me? They gave me a decimal and they want me to turn it into a percent. Well, this tells me what I'm going to do. I'm going to pick up my decimal and I'm going to whoop whoop to the right because the whoop whoop is written on the right. So you pick up your decimal and you move it 2 times to the right. So I'm going to pick up this decimal and I'm going to whoop whoop to the right. I put a 0 in the hole, and so my answer is going to be 250%. It's always a whoop whoop. It's never a whoop. It's never a whoop whoop whoop. It's always a whoop whoop. Okay? So what if I said write 1/7% as a decimal? Well, this is when I have people say, well, Ms. Cooper, where is the decimal? Well, if y'all have $17, where's the decimal in $17?
Behind the 7.
Behind the 7. Well, we are going from a percentage to a decimal. So which side is the whoop whoop on?
Beside the 7.
The left. So we are going to pick up our decimal and we are going to whoop whoop to the left. So my answer is going to be 0.17. I did not need to add zeros because I did not jump an empty space. Feel better about that? I think you were working on that one today too. And it says multiply, whoop whooping to the left is dividing by 100. Whoop whooping to the right is multiplying by 100. You're using the mathematical stuff. I just can't remember when do I multiply, when do I divide. So it's just like Beyonce, to the left, to the left. I mean, who thought she was talking about changing a decimal to a percent, or percent to a decimal? That's what her songs are about. Not really, but that's what they are in my head.
Everything on to the left.
All right, now, rounding. We're going to get into that today. Some of the problems that y'all do want you to round first. Some of the problems want you to round last. So sometimes I will give you a problem like 17,486 divided by 8943, and I will say round to the thousands first. Let me change that to a plus. Round to the thousands first. So if I do that, you've got to tell me what digit is in the thousand spot. So what is in the thousand spot for the first number?
7.
The 7. The 4 tells the 7 what to do.
Stay the same.
So if the back number is 0 to 4, the underline is going to stay the same. If the back number is 5 to 9, the underline is going to go up. So because my back number is between 0 and 4, my underline stays the same. Everything in front drops, everything behind turns to zeros. Now for the next one, where is my thousands? What digit is in my thousands?
8.
The 8. The 9 tells the 8 what to do. My back number is between what and what? 5 and 9. So my underline is going to go
Up.
up. There is nothing in front of it, but what does everything behind it do?
0.
Turns into zeros. Now, because it told me to round first, I round the problem. Now I go to my calculator and I type it in. So it's going to be 17,000 plus 9,000. If you type it in and round it, you're probably going to get the wrong answer. Just FYI. So for this one, the answer is going to be 26,000. Now, sometimes it's going to say 4.23 divided by 0.6, round the answer to the nearest hundredth. And we're going to talk about place values in just a minute. But for just to show you the difference, you have to round when they tell you to. This one is saying round the answer, which means I'm going to type the problem in as it is. And of course it's not going to be one that I can round. That one came out pretty. 4.235 divided by 0.6. There we go. So now it wants me to round to the hundredths. What digit is in the hundredth spot?
5.
The 5 is in the hundredth spot. So once again, the number behind tells that what to do.
Go up.
So the 8 tells the 5
Go up.
to go up to a
6.
6. Everything in front remains the same. Everything behind drops off or turns to zeros. We cool? Now, one more that we need to go over before we start talking about Module 2. This one was a pie graph, pie chart, and they said that the total chart represents 95,000 people. We want to know how many people chose a bird. So 23% chose a bird. Now, to me, this problem is screaming off of my formula sheet. So if I come over here and I pull up my formula sheet, come on, syllabus and handouts, I go to my formula sheet, and y'all have a purple copy, but I'm going to pull up my formula sheet, and we talked about this last time. We talked about is over of, and we started talking about this A over B. Now, this problem is not talking about tip, it's not talking about tax, but it is talking about part and whole. Part over whole equals percent over 100. Now, where do you think the 23 is going? What is the 23?
It's a percent.
That's my percent. Now, I only have one more number left. My other number's I need to do it in a different color. My other number is going to be 95,000. What does that represent?
The whole.
That represents the whole graph. So my whole is going to be 95,000. I'm trying to find the part of the people that like a bird. So I'm trying to find the X, the part. Now, I want to cross multiply. So when I cross multiply, what two numbers do I need to multiply?
23.
25,023.
I multiply the two numbers that are diagonally across from each other, and then I divide by the loner. So I'm going to multiply 95,000 times 23, and then divide by 100. So this is how many people like a bird. Now, this one actually could be done using the shortcut method. The shortcut method is 23% of 95,000. The shortcut method can only be used if you're doing a certain percent of a number. Now, if you're doing the shortcut method, you got the whoop whoop. So what is 23% as a decimal?
0.23.
0.23. And what does the word of mean in math? Times. So you could have done 0.23 times 95,000. The shortcut method does not always work, but when it does work, it's easier. But you just have to remember that if you do the shortcut method, you have to whoop whoop. If you do part over whole, or is over of, or tax over difference, or commission over total, you don't whoop whoop, because this is really the whoop whoop. So if you whoop whoop and then use this formula, you're really whoop 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 whooping. So your question when you do this is to whoop whoop or not to whoop whoop. That is the question. So I always use this one so that I have to say I don't need to whoop whoop because it knows it's a percentage. Now, one more thing that I happen to think about. All right, y'all, I'm back. One more thing that I want to think about. We've had some problems. I've had more than one of you come up to me about compound interest.
What?
Compound interest, if you haven't gotten to it yet. It'll have a problem like you want to borrow $8,000 compounded semi-annually for, this is where I'm going to take a minute to talk to you about real life. A lot of your teachers assume that y'all know stuff that you don't know, and this is one of those things. If you need to buy a car, $8,000 is not going to be, it's going to be a used 4 or 5-year-old car. Okay? Now, let me change it. Let's not even do compounded semi-annually. How often do you pay for your car? Monthly. So it would be compounded monthly. How long does it take you to pay off a car?
Years.
How many years?
Probably about 3, 4, 5.
How many years does it take most people to pay off a car?
5.
6.
5 to 7 years. 5 to 7 years. What's the percentage rate right now for cars? Anybody know?
2.9. Is
Okay.
that usually what it is?
Let's say, and y'all, listen, guys, this is real life. We need to listen. Your percentage rate is based on your credit. And just to give you a little real life history, so a lot of you in here are young. Some of us are not so young, but a lot of you in here are young. And when you go to start putting stuff in your name, they're going to say, you have no credit. And then they're going to say, oh, well, I have to have credit to get credit. How am I going to get credit? Well, here's how you do it. And I'll tell you, my daughter right now is in 6th grade. When I was in 7th grade, my parents got me a checking account, a savings account, and a credit card. And this is when, and I see Katie's eyes going, what? What my parents did, my mom's a math teacher, my daddy's an engineer, so they understood. They got me a credit card with only like $100 deductible, $100 limit. And they let me go, to Claire's, or they let me go buy a shirt, or when I got older, they let me put the gas in the car, or whatever. And they made sure they paid it off, and then when I got a job, they made sure, even though it was in my name, they made sure that I was paying it off. And what they were doing from the time I was in 7th grade
Is
is
establishing
they were
credit.
establishing my credit. So that when I graduated high school and graduated college and I got married at 21 and bought my first house at 21, I had credit. So that when I go buy a house, my interest rate is based on my credit. Now, when I married my baby daddy at 21, his parents did what most of y'all's parents did. If he needed gas money, they gave him gas money. If he needed a credit card, they let him borrow the credit card, or they gave him a check or whatever, so that when he graduated high school, he had no credit. Now, for those of you who don't know what credit is, that's proving to the world that you can pay your bills. Now, some of you pay your bills, but you may pay your bills to your parents, and then your parents pay them. That's establishing credit through your parents, not through you.
Or a credit company.
Or, right. So, when my husband and I, first husband and I, went to go buy our house, you know, you're just married, 21, you want the house to be in y'all's name or his name. We didn't put it in his name because our interest rate would have been out the roof because he had no credit. He had not proven to the world that he could pay his bills. So everything had to be in my name so that we could get a lower interest rate. So we had to spend years putting things slowly in his name to build up his credit. So his parents didn't realize they were doing a disjustice to him by not putting things in his name. So Madison will have a credit card, okay? But I will make sure that she pays it. Now, another thing, and again, I know a lot of you are young, don't go home and say, Ms. Cooper said, I need a credit card, because that's not what I'm saying. But credit cards get a bad rap, but they can be used for good things. For example, I only use credit cards to pay my bills and to pay anything. I never carry cash. I probably have 20 credit cards. But I pay my credit cards off every month, and I use credit cards to save money. For example, if I go to Lowe's, you get 5% off. If I go to Target, I get 5% off. If I buy in from Walmart, I get 3% off gas. If I use my Visa card, I get cash back. So I go on trips every summer by using my cash back because I'm going to be using that money anyway. But as long as I pay off at the end of the month what I charge, then my credit cards are not a bad thing. What gets you in trouble is if you charge more than you can pay. So credit card companies hate me because they're not making any money off of me. So when they send you a bill saying, oh, you only need to pay $20, that's your minimum payment, that's where y'all get screwed because you pay that $20 and say, I'll worry about it next month.
Because then the interest.
Because the interest is what gets you. So if I charge $146.23, I'm going to pay $146.23 and I don't owe any extra. Does that make sense? Mm-hmm. Now, another thing, I have a lot of teenager kids or young adults say, how do I establish credit? There's a lot of that. Now, some banks won't give you a loan or anything if you don't have credit, but some banks will. So what you do is you go to a bank. Some of them will give student loans. Even if you don't need any money, you go to a bank and you say, can I borrow $200 or whatever? Even if you don't need it, get the $200 that you don't need and put into a savings account or put up underneath your bed for 6 months. Now, they may charge you $20 in interest or $30 in interest. But what you're doing is you're saying, okay, I've got to pay back $25 every month or whatever the payment is. But over a 6-month period, you didn't need that $200, but you borrowed it. And you're going to pay it back on time, if not early, to prove to the world that you can make those payments. Now, if you borrow the $200 and you pay it back late, or you pay it back, or don't pay it back, or miss a payment, then you're proving to the world that you can't pay it back, which is worse than no credit. Which is why these check and go places kill y'all. They charge you the high interest rates because they know, like when you, these title loan places, like if you need to borrow money, there's these places that say, I'll cash your check, but I'm going to charge you this outrageous interest rate because they know that you don't have any credit.
And most of those like 28, 29%.
Right. And so you've got to establish credit somehow. And the best way to do it is to borrow money when you don't need the money and start establishing credit that way. Now, this compound interest is showing you about good interest versus bad interest. When Madison was 5 weeks old and got her Social Security card, The first thing I did, I started her savings account. And my baby daddy was like, what are you doing? She's 5 weeks old. She doesn't need a savings account. But every time I get like a refund check, that I'm not expecting, $25 rebate check, or, she gets $100 here or there for her birthday, I put it into that account. And then she's 11 years old now. I have over $5,000 in that account. She knows about that account. She gets that little receipt, and it has her name on it. It has my name and her name on it. She knows she has that. But she is learning about good interest. She makes $2 and some change every month just for that sitting in that account. But she knows if she needs money, she can go in there and get it. I still monitor how she spends it, but she knows that this is for her college or for her car, for whatever. But she's learning about good interest versus bad interest. It's all in how you teach. Okay? So, for this problem, we're buying a car, and we need to borrow some money. We borrow $8,000 compounded monthly for 5 years at 3.5% interest. Now, on your formula sheet, you do have a formula for compound interest. Here is the formula. It looks like a booger, but it's not that bad. Now, here's our formula. P stands for how much money we're going to borrow. I'm just going to go through all the letters first, and then we're going to plug them in. P is how much money we're going to borrow. R is our percent as a decimal. That means that we're going to have to whoop it. Whoop, whoop. Now, we have 2 N's. This is what gets everybody. Our N's is how it's compounded. So if the problem says compounded annually, you have a birthday annually. How often is that?
Once a year.
That is once a year. So if it says annually, that means once a year. If it says semi-annually, Belks has a semi-annual sale. That means every 6 months, twice a year. They have it in the fall and they have it in the spring. Very good. If the problem says quarterly, 4 quarters make $1. Taylor was holding up 4. 4 quarters make $1. 4 quarters in a football game. If it says compounded monthly, how many months are in a year?
12.
12. If it says daily, how many days are in a year?
365.
365. And then we have a T. The T says our time. How long does it take us to pay back the loan? Are we paying back in the loan in 2 years, or are we paying it back in 5 years? So, for this problem, and the A stands for the all that we're paying back, which means what we borrowed plus the interest. So the A that we're going to get as our answer is the $8,000 plus whatever the interest is. So for this particular problem, what is my P? What am I borrowing?
Mine, 8,000.
$8,000. 1 plus, my percentage rate is 3.5. So if I whoop, the 3 point, see I'm changing my percent into a decimal, so we're going percent to decimal, so we are going to whoop which way?
To the right.
2 to the other right.
To the left. Yeah.
2 to the left. So when we whoop to the left, what is that going to give me?
0.035.
0.035. We are going to divide it by n. What is my n going to be? How often is it compounded? Monthly? So that is going to be 12. So we put a 12 there and a 12 there because I have 2 n's. And then I multiply that by the time. How long is it going to take me to pay off my loan?
5 years.
5 years. Now, this is where you're going to get in trouble. The easiest way to do this problem is to clean up your double exponent. So we're going to go to our calculator and we're going to clean up the 12 times 5. 12 times 5 gives me 60. So that's going to be 60. Now we type it into the calculator. 8,000 parentheses 1 plus 0.035 divided by 12, close it. hold on, I've got my calculator in the wrong mode because I want to be able to show you the whole problem at once. So I'm going to put it in classic mode, and I want 8,000 parentheses, 1 plus 0.035 divided by 12, close it, and raise it to the 60th power. Oh, I didn't get my to the in there. To the 60th power. So, A is money. Money is always 2 places behind the decimal, because change